right. Good morning, folks in APAC. My name is Ananda Bose, and I work as a director managing the Northeast and Canada solution engineering teams at Confluent, and I'm based in Virginia in the US. So today I'm going to speak about data modernization using Yugabyte and Confluent. And what I'm going to focus on today is what are the tenets for faster application development, what kind of challenges monoliths encounter, and what about inter-service communication, which is the big part because that's where data comes in. Why Confluent and Yugabyte, and finally to sign off, what are the key benefits if you do this properly, right? So I'm based in Virginia. I used to live in Singapore. I just moved to the US, and I've worked with North American as well as emerging market clients in Confluent, Pivotal, Avanade, Microsoft, etc. My specialization is, excuse me, is application modernization techniques, as well as microservices design for financial services. And I don't say I'm like super good at database modernization, but I'm consistently getting better at database modernization. In my current role, as the director of solution engineering for Northeastern Canada, I'm extremely privileged to work with a team of extraordinary solution engineers who assist our clients in Confluent across the US Northeast and Canada. Just put some publications that I had written in the past, and these were from Pivotal. And in case anyone is interested in positions in Canada or the Northeast, please let me know because I'm actually hiring. So moving on, what are the tenets of faster application development, especially when you're looking at modern application development? So the first one is elimination of dependencies. And in this, what we can talk about is, the concept of having independent services working on independent data. And, therefore, there are no dependencies between the UX, the microservices, as well as the backend data that is being requested. This is also used to build and scale, internet grade apps. And COVID has accelerated this significantly because COVID obviously has created a massive digital wave. It's probably not going to be easy to say no to this in the future. And last but not the rest, this is a fantastic mechanism by which you can reduce technical debt and TCO. So what are the biggest challenges of monoliths? The biggest challenges of monoliths is that the business logic is actually all across. It's in the UX, it's in the middleware, it's in the BPM layers, it's in the database. And depending on how old your systems are, it could have as much complexity as web services, stored procedures, all kind of complexities that are there. So what happens is that even if you request a small change, the impact analysis itself is going to be huge. Now, because of that, what happens is that if the testing time becomes large and your time to market reduces significantly, extends significantly. So because of this model that we have actually used in the past, a simple error can bring down the entire app, right? And since there's so much risk as well as skills availability, the entire tech stack is super expensive. And thus it is, a huge barrier to get new programming frameworks, right? On the other hand, there is a massive wave in terms of adoption of microservices. Why microservices? Since they are independent and they only deal with small parts of business logic, what has happened is that it has resulted in faster release cycles, and as well as new deployment models have created, improved scalability and reliability. So which means that, you can actually scale these applications from 0 to very large numbers and again, bring it down to 0, right? That's actually cloud native development. And last but not the least, in terms of how you build microservices, there's a lot of developer autonomy because now you have standards as well as clients that allow you to build in the language of your choice and just deploy or connect using mechanisms that are actually available in this particular pattern. So moving on, the big challenge comes not in terms of redoing your application side of the puzzle, but where the challenge comes is how do you actually break down the data monolith. So data in the world is typically stored in enterprises, in Oracle, in mainframes, Hadoop, etc., etc. The digital native world does have a better handle on data as they are born in the cloud, but even then they still get into certain problems, when they use RDS or some of the other relational databases. So what happens then is typically there is a choice that you typically use. So either use REST APIs, which is a synchronous model for request response kind of communication, or use message queues. And these are quite popular. And of course, there is a huge emergent population that uses Kafka. So if you use REST APIs, what happens is that you sort of get into a P2P kind of spaghetti mesh. And what the reason for that is that there is tight coupling, which means that the business logic is rewritten multiple times any time a new request comes, right? And scaling this becomes quite difficult because if you have errors, it is difficult to actually get back and recover from that. So given these complexities, REST APIs, especially if it proliferates in an organization, even with an API gateway, sometimes becomes quite difficult to manage and it's quite expensive, as a mechanism in which to do inter-service communication. The other option is to use traditional message queues. So message queues have some scaling problems. They are broker based, and most of them are actually not really based on modern cloud native deployment architectures. So because of that, there is a lot of inter-team dependencies, and more importantly, this dynamic scaling, which is sort of a necessary requirement of a 12-factor app or a cloud native app, is just not possible. And last but not the least, message queues were built for traditional enterprise apps, and they have difficulty, definitely with integrating with cloud native apps, which are different in mechanism, and as a result of which, it becomes quite difficult sometimes to get all of this working together, and you see a lot of glitches. Transport apps, for example, where you don't see the car coming at the right speed at which it should come, and all of these kind of problems that you actually encounter. So moving on, how can Confluent and Yugabyte actually solve this problem, and why should you look at Confluent and Yugabyte, right? So Confluent is, based on Apache Kafka, and our founders were the creators of the original Apache Kafka, and we are a public company which has created a new paradigm for data in motion. And the biggest example of that is that we move from data at rest to data at motion, because if you look at business, you typically look at business in the form of events. And events means a shipment, a customer experience, a trade, etc. And most of the events actually happen in real time. So Confluent created this platform using Apache Kafka and a series of intellectual property on top of it, like role-based access control, connectors, and we'll talk about that more when we talk about how we connect to Yugabyte, as well as a variety of mechanisms like clients, REST proxies, etc., that allows to then create never before rich front-end customer experiences, as well as real-time back-end operations. So think fraud management in real time, think mobile applications for account balances, and a variety of use cases across all industry. So if you hear from KeyBank, KeyBank says that with Confluent we are making data available via event streams, which means that their integration to the backend systems typically is much faster today than what it would have been earlier. And he says something very interesting where he said that a project that would take 3 months today takes significantly less time and effort. Now, then comes Yugabyte. Now, Yugabyte is a database built for the cloud, which means that it's a very high performance distributed SQL database for building global internet scale data services, which means two things, right? One is it's distributed SQL, which means it's built for distributed operations. And second is it's cloud native, which means that it has scale, elasticity, and a variety of these functions. So when Confluent comes, and this is more at the source of data, what Confluent does is it allows you to do async data transfer. And when you do async data transfer, one of the biggest things that you can do is offload of your backend data sources. We allow you to use PubSub, and there are a variety of mechanisms by which you can use it. We allowed it to be deployed on Kubernetes. We allow you to deploy on Confluent Cloud, which is available on AWS, Google, and Microsoft in all regions in Asia, as well as Alibaba Cloud, which is specific in China. And because of that, we can allow you, elastic scalability. We can allow you persistent storage, especially for S3 compliant storage, which means that you never have to leave any event. And because we have various mechanisms to process data, you might have heard of K-streams and KSQL. K-streams with Java-based real-time processing, and KSQL means SQL-based real-time processing. We can process data in flight as well as real-time. Now, what happens then? When you do these kind of things, the first one is that the developer velocity increases significantly, because they don't need to worry about how to provision this, how to manage this, etc., etc. We have a capability called schema registry, which ensures that the data and the validation of how the data is coming is done. So as a result, there is no bottlenecks and dependencies and checks that you have to do as a developer. And last but not the least, whether you're using KSQL, if you're a SQL lover, or you're using K-streams, if you're a Java lover, you can really build, real-time contextual applications, right? The second one, now, since we have this capability of scalability, elasticity, both on the cloud as well as leveraging, Kubernetes, CNCF compliant Kubernetes, as well as storage systems, we can build highly reliable and fault tolerant microservices. So in that, we have infinite storage available on the cloud as well as on-prem with certified storage vendors. And we can run it, not just in a single cluster, but across multiple DCs or availability zones, which means you have zero data loss solutions and always available solution. And last but not the least, especially for enterprises, we can provide you with end-to-end stream governance. So using 1 and 2, what we can do is we can significantly reduce the technical debt and messaging TCO. So the first one is that we have 120 plus connectors. Now these connectors can go from Oracle, from mainframes to Salesforce, all kinds of things. And we have a concept known as source and sink, and I'll explain that shortly in context of Yugabyte. But source connectors are connectors that connect, let's say, to IBM information replication, or Attenuity or Oracle databases, and allow you to get a stream of events as they happen from these backend databases. A sink connector, on the other hand, is a connector that takes process data and puts it into a Yugabyte or any of the downstream databases that actually need this system. One is that. The second one is a extremely interesting, new feature that we have launched called cluster linking, because what it allows you to get into a truly hybrid architecture. In the hybrid architecture, what you can do is that you can link clusters on-prem, on the cloud, multi-cloud, giving you the capability to actually harness real-time data, not just, in one or two circumstances, but a variety of permutation and combination. And last but not the least, since 80% of the commits to Apache Kafka is done by Confluent, you're with the best, and our support is actually willing to help you to go the extra mile and provide a lot of value, wherever you need it during your life cycle with us. So how do we do it, right? What we do is that typically, let's say we have a mainframe, we will use a CDC connector. It could be, in case of a mainframe like IIDR from IBM, it could be Attenuity, or in Oracle, we have our own Premier connector or Golden Gate. And then what we do is, using this connector, we offload it into different topics. And once we have this topic, we can either put it into Yugabyte, or you can consume directly into, Yugabyte, Postgres, etc., etc. And you can consume it directly, even off topics, because we have the ability to process this data. The second one is that a lot of databases, for example, use message queues. This could be TIBCO, this could be IBM message queue, and a variety of other functions, right? So what we can also allow you to do using the same mechanism of connectors is to decouple the MQ from your application. So which means MQ application or JMS application streams will come into Confluent. And for the newer applications that you're building, you can directly get off Kafka, and the microservices use a pub/sub model and then get all of this information. Because we have K streams and KSQL, not only do you just get plain transport, you also have the ability to process this information. Processing can be a variety of things. It could be, sorting, it could be summing, it could be, using foreign keys, variety of things. And most importantly, because we govern this using schema registries, using, a variety of controls, whatever data the microservice is getting is always going to be in the right format, and possibly, the richest data currently coming in from wherever it was designed. So here's an example of how Confluent and Yugabyte work together. So we have different kinds of backend devices. This could be devices, it could be sensors, it could be apps. And using either, connectors or standard, native Kafka streams, etc., we get all of this into Confluent. And in Confluent, there are mechanisms by which we can send it using us. So on the left, these are what are known as source connectors, and we have 120 plus of them, which allow you to connect to most known systems, both on the cloud as well as on-prem. Once you have this data, you have multiple options. So you can pass it using a sync connector to Yugabyte. And Yugabyte, you guys know better than me, but Yugabyte, you can do the processing there. And then through Yugabyte, you can put them into real-time dashboards or, alerts, notification, as well as microservice consumption. Or you can use K-streams or KSQL and actually do real-time processing. And you can send the materialized view to Yugabyte, or you can have other services that are subscribing to this. So I hope in this little talk that I did today, I gave you a view of not just what Confluent does, but also how Confluent and Yugabyte can come together. So thank you so much for your for your time today. And now what we'll do is we'll open the discussion for questions.